Hi, good morning, children. In the previous class, we learned how to find a inverse of a matrix using its cofactors. Dear children, in this class, we shall be discussing the application of determinants and matrices to solve a system of linear equations of two or more variables. So, by checking the consistency of a linear equations. So, we have here two terminology, that is consistent and inconsistent, or this is a consistency and inconsistency. Here, then what do you mean by consistent? Any system of linear equations are said to be consistent if on only if there exists a solution. There exists a solution. The solution may be one or more. Okay. Generally, we say that if solution has only one, then we say that it is nothing but a unique solution. If the solutions are more, then we say that it is infinite solutions, infinite number of solutions. Again, any system of linear equations are said to be consistent if and only if there exists a solutions. It may be one or more number of solutions. If it has only one solution, then we call it as what? A unique solution. More number of solutions, then we say that it has an infinite number of solutions. Here then we have inconsistent. Then what do you mean by inconsistent? So any system of linear equations are said to be inconsistent if and only if there is no solution. There is no solution. If solution does not exist, then we say such a systems are said to be inconsistent. Here, simple. For example, consider a1x plus b1y is equals to d1. a2x plus b2y is equals to d2. So these are the general lines. Okay, if these lines intersect each other, then we have what? Solution. If the lines are parallel, the lines are parallel, there is no solution. We can't find the value of x. Okay. Here before that, what is the solution means finding the values of x and y variables. Finding the values of x and y. Here the lines are parallel, we can't find the values of x and y. Okay, if the lines overlap on each other, overlapping lines, okay, we have what? Infinite number of points here. Okay, infinite number of points here. Then such is called as infinite number of solutions. The point lines intersect, then we say that it is what? A unique solution. Okay, so remember this. So there are one we have a consistent and then we have inconsistency. Any system of linear equations are said to be consistent if and only if there exists solution. It may be one or more number of solutions, that is unique solution and infinite number of solutions. In our syllabus, we have only what? A unique solution. If solution does not exist, then we say that type of system of linear equations has inconsistence. Okay, so now it has been in our syllabus, it has been restricted to what? A unique solution. It means what? So when does the solution exist? If and only if the matrix is a singular, non-singular matrix. The matrix is what? Non-singular matrix. So we have already know what is non-singular. A determinant of matrix is not equal to 0. Not equals to 0. determinant of matrix is not equal to 0, then such a thing is called as what? Non-singular matrix. A non-singular matrix can have a unique solution or infinite number of solutions. We can say just if a matrix is singular non-singular matrix, then we say the solution exists. Here, if determinant of A is not equal to 0, then we say that the inverse of a matrix does not exist. Does not exist. Just remember this, okay? So now let us solve system of linear equations. So let a1x plus b1y plus c1z is equals to d1, a2x plus b2y plus c2z is equals to d2, and a3x plus b3y plus c3z is equal to d3. Be any three system of linear equations with three variables. With what? Three variables. Usually, so these are called as linear equations. So now this equations can be written as like this. That is, A is equals to matrix. So writing the coefficients of the variables, that is x, y, and z. Here the coefficient of x is a1, coefficient of y b1, coefficient of z c1. So writing the coefficients of the equations. Okay. So before writing the coefficient of in each equation, see that the variable should be one side and the constant should be other side. So now I like this. A is equals to writing the coefficients of the variables, that is a1, b1, c1. Similarly, a2, b2 and c2, a3, b3, c3. Okay. Now x is equal to variable matrix. Just writing the variables, that is x, y, z. So that is x, y, z. Then write constant matrix as B matrix. B is equal to constant matrix. Here what are the constants? That is d1, d2, d3 are constants. So d1, d2 and d3. Okay. See, now this matrix is called as what? Coefficient matrix. Coefficient matrix, and this is called as variable matrix, and this is called as constant matrix. So now this is matrix can be written as A x is equals to B. X is equals to B. Now this can be written as what? A x is equal to B. Just multiply A with x. Will get and equal to constant matrix. Will get same equations. For example, A1 into x plus B1 into y plus C1 into z is equal to D1. Will get what? Same equations. Therefore, this can be written as Ax is equals to B. X is equals to B. So now, if A is non-singular matrix, if A is a non-singular matrix, okay. So therefore, that will just multiply, pre-multiply. That will have to pre-multiply by A inverse, So just therefore, that is A inverse into A into x is equals to A inverse into B, right? Just pre-multiply by A inverse. So we know that A inverse into A gives I, that is identity matrix. Okay, that is equals to again A inverse into B, A inverse into B. So we remember this. Any matrix multiplied by its inverse gives the identity matrix itself, identity matrix. Okay, here any matrix multiplied by, so identity matrix gives the matrix itself. Therefore, x is equals to A inverse into B, A inverse into B. So usually by using what is x? X is a variable matrix. X is a variable matrix having variables x, y, z. Therefore, this is used to find the variables x, y, z. So we know that how to find A inverse. How to find A inverse? So A inverse is equals to 1 divided by a determinant of A into adjoint A, adjoint of a matrix. Okay, right? Again, so given system of linear equations can be written as Ax is equal to B. That is, first one is called as what? Coefficient matrix, and this is called as variable matrix and a constant matrix. Therefore, free multiply the given equation by what? A inverse. Therefore, we have A inverse into A into x is equals to A inverse into B. So we have A inverse into A gives ID matrix. That means any matrix multiplied by its inverse gives ID matrix. Again, here any matrix multiplied by ID matrix gives the matrix itself. Therefore, x is equals to A inverse into B. So we know how to find A inverse. The A inverse is equals to 1 divided by determinant of A into adjoint A. Right? Okay, children, you will understand this. Okay, right? So now we'll solve some problems that you can answer easily. Okay. Here we have a system of linear equations. X plus y, sorry, x minus y plus z is equals to 4. Then we have 2x plus y minus 3z minus 3z is equals to 0. Then we have x plus y plus z is equals to 2. Okay, so we have equations. We have equation that is x minus y plus z is equal to 4, 2x plus y minus 3z is equal to 0, x plus y plus z is equals to 0. So now this equation can be written as, that is, A is equal to, write the coefficient matrix. So here we have coefficient of x 1, coefficient of y minus 1, coefficient of z 1, here coefficient of x 2, coefficient of y 1, coefficient of z minus 3, again coefficient of x 1, coefficient of y 1, coefficient of z 1. Okay, then we have a variable matrix, that is x is equals to variables. What are variables? X, y, z. Then we have a constant matrix. What is constant matrix here? Constant, that is 4 0 2, 4 0 2. So now we have to find a cofactor of each element. So we know how to find that. That is A11 is equals to plus, that is 1 plus 1 2. We have even number, therefore write plus. So plus of determinant of, so leaving this the cofactor of, I already told you that the cofactor of any element can be obtained by deleting the row and column, of element which you are considering. Write the remaining elements in determinant form. Writing the remaining element in the determinant form by deleting ith row and jth column and multiply an appropriate sign, and we get cofactors. So that is plus of leaving this entire row and column, we have 1 minus 3 1 1. Again that is equals to 1 into 1, we have 1. We have minus 1 into minus 3, minus of minus we have plus 3. So again that is equals to 4, Similarly we have cofactor of A12, that is equals to, so we have sign, that is minus into determinant of leaving this entire column and row, we have 2 minus 3 1 1. Again that is equals to minus of, write this minus as it is. So that is 2 into 1 2 minus 1 into 3. So we have minus 3, minus of minus plus 3. So that is 3. Again 2 plus 3 5 into minus 1, we have minus 5. Again cofactor of its element A13, that is equals to this one, that is plus in determinant of leaving this entire column and row we have that is 2 1 1 1 2 1 1 1 again that is equals to, so that is plus of 2 into 1 2 minus 1 into 1 1, so 2 minus 1 we have 1 that is equals to 1 itself. Next cofactor of a1 a2 1 that is equals to minus into determinant of, so leaving this entire row and column we have so that is minus 1, then we have 1, we have 1 1 again that is equals to minus of minus 1 into 1 we have minus 1 minus 1 into 1 we have 1, okay, again that is equals to minus 1 minus 1 minus 2 into minus we have plus 2, again cofactor of next element a 2 2 that is equals to plus into determinant of cofactor of this element leaving this entire row and column we have 1 1 1 1 1 1 1 again that is equals to, so that is plus of 1 into 1 we have 1 minus 1 into 1 we have 1, what is 1 minus 1 we have 0. Next cofactor of next element a 2 3 a 2 3, okay, again that is equals to minus into determinant of cofactor of this element leaving this entire column and row we have 1 minus 1 and then 1 1 again that is equal to minus of 1 into 1 1 minus 1 into minus 1 we have minus 1 minus of minus plus 1 again that is equal to 2 2 into minus 1 that is equals to minus 2 minus 2. Next cofactor of next element a3 1 that is equals to plus into determinant of cofactor of this element, so we have leaving this row and column, so that is minus 1 1, then we have 1 minus 3 again that is equals to, so minus 1 into minus 3 we have plus of 3, again minus 1 into 1 we have 1, again that is equals to 2. Next so cofactor of a3 2 is equals to minus in determinant of, so cofactor of this element leaving this column and row we have 1 1 2 minus 3, so 1 1 2 minus 3 again that is equal to minus of 1 into minus 3 we have minus 3 minus 2 into 1, so 2 that is equals to, so minus 3 minus 2 have minus 5 minus into minus becomes plus, that is plus 5 again, so cofactor of a3 3 that is equals to minus plus of, so cofactor of this element leaving this column and row we have 2 minus 1 sorry 1 minus 1 2 1 again that is equals to plus of, so 1 into 1 1 minus 2 into minus 1 we have minus 2 minus of minus plus 2 that is equals to 3, that is equals to 3. So now we got cofactor of each and every element. Now we write adjoint matrix. Therefore adjoint A is equals to transpose of coefficient matrix, transpose of a coefficient matrix, that is sorry transpose of cofactor matrix. So we will write 4 minus 5 1 again 2 0 minus 2 again we have 2 5 then we have 3. So this is what adjoint of A. Then we need to find the determinant of A. Therefore determinant of A is equals to a formula, that is A11 into capital A11 plus A12 into capital A12 plus A13 into capital A13. Okay, so that is equal to, what is small a11? We have 1. What is capital A11? We have 4. 1 into 4 we have 4 again plus small a12 we have minus 1. Capital A12 we have minus 5. So minus into minus 5, that is we have a 5 again plus we have, what is small a13? We have 1. What is capital A13? We have 1. 1 into 1 we have 1 again, that is equals to, so we have 10. So this is what determinant of A. So now we have to find what. So that is x is equals to A inverse into B. A inverse into B. Again, that's equals to, what is A inverse? 1 divided by determinant of A into or joint A into B. Right? So again, that is equals to, or right here. Okay. So that is equals to, so what is A inverse? 1 divided by determinant of A. So that is 1 divided by determinant of A. What is determinant of A value? We have 10, right? Into adjoint matrix. What is the adjoint matrix here? We have, so that is 4, 2, again minus 5, we have 0, and again 5, again 1, we have minus 2, again we have 3, into constant matrix, that is P matrix. What is P matrix here? So we have 4, 0, 2, 4, 0, 2, right? So now we have to find the product of two matrices. What find what? Product of two matrices. Okay. So right. So now how to find a product of two matrices? So that is equals to 1 by 10 into. So we know how to find product of two matrices. First row with the first column, right? So that is 4 into 4 we have 16. Again 0 into 2 we have 0. Again 2 into 2 we have 4, right? Okay. So again here we have so minus 5 into 4, that is minus 20. 0 into 0 we have 0. Again 5, that is 5 into 2 we have 10 plus 10. Okay. Again so we have here, so 1 into 4, that is 4. Again minus 2 into 0 we have 0. So 2 into 3 we have 6. Okay. Right. See again 4 into 4, 16. 2 into 0, 0. Again 4 into 2 into 2 we have 4. 5 into 4 minus 20. Again 0 into 0, that is 0. 5 into 2 10. 1 into 4 4. Minus 2 into 0 0. 3 into 2, that is 6. Again simplification, that is equals to 1 by 10 half. So here we have 16 plus 4, 20. Okay. So minus 20 plus 10, we have minus 10, minus 10. Again we have 4 plus 6, that is 10. Okay. Therefore again that is equals to, multiply 1 by 2 to each element. 20 by 10 we have 2. 10 by minus 10 by 10 we have minus 1. 10 by 10 we have 1. Okay. So therefore, so what is this x? So what is x? X is equal to x, y, z. Therefore x is equals to, we have 2, y is equals to minus 1, and z is equals to 1. So this is what the solution or the values of x, y, z. Values of x, y, z. Okay. So if what, you can make a note of this.